So let us share the document. Okay, do you see the screen now?
No, we can't see it.
Not yet.
Okay, I will just I shared it. I don't know what's the problem. Let me try again.
Now we can see them.
Ah, you can see it now? Okay. Yeah. So let us start.
But it appears as if it's frozen.
Now,
Okay, now.
now
Yeah. Now we can.
yeah. Okay. So we have that the lifetime of a turbine is given to be 20 years, and the turbine is characterized by a power of 3 kilowatt. So power of the turbine is 3 kilowatt. The lifetime of the turbine is 20 years. So this is N. And we have that the initial capital cost is 2,000 euros per kilowatt. So here, for example, since the power of my wind turbine is 3 kilowatt, and since the cost is given per kilowatt, so I can assess from here the initial cost, which is also called investment. Okay, so in any project, you have a certain investment, which is money you should put at the beginning of the project to make it feasible. So here the investment will be equal to 2,000 times 3, because we need 2,000 euros per kilowatt, and since our wind turbine is characterized by a power of 3 kilowatt, so the investment will be 2,000 times 3 equals to 6,000. 6,000 euros. Okay. Now, the yearly maintenance cost is equal to 2% of the capital cost. So when we talk about any project, we have yearly, sometimes we have operational cost, and we have maintenance cost. So in general, the costs can be divided into two parts. We have maintenance issues, and we have the operational costs to operate our system. Okay. Sometimes we don't have operational costs, we just have maintenance costs. So it depends on what the project is. Okay. Now, concerning the salvage value, when they talk about a salvage value, what do they mean by this? So you know that any equipment after a certain period of time will not work in appropriate ways, and we say that it is the end of lifetime of this equipment. But even at this time, you can just buy some of its, sell some of its parts, and you can sell it. As for cars, for example, okay, بيقولوا إنه للكسر معناها. And you can just take the parts of it and you can sell them. This is why for any equipment or any project after the end of life, you can still sell this equipment with a certain amount of money. So this is called the salvage value. Okay. So here the salvage value is given to be 400 euros. Now, the turbine generates 7,500 kilowatt hour per year. This is what we care about, because at the end, why we are using the wind turbine? We are using the wind turbine in order to reduce our electricity consumption. So we don't want to pay the electricity bill. We want to use renewable energy to produce electricity, for example. Okay. So in this case, instead of having an electricity bill, the wind turbine can give us a certain replacement, and it can generate for us 7,500 kilowatt hour per year. Okay, so this is, if you want, the benefit we will have. So when we will balance between the cost and the incomes, this is our income. And in order to know what is the income money, we should know what is the cost of a kilowatt hour. Okay, so we have that the selling price of a kilowatt hour generated by a wind turbine will be 0.13 euros per kilowatt hour for the first year, 0.12 euros per kilowatt hour for the second year, and 0.11 euros per kilowatt hour for the third year. And finally, it will give us 0.1 euros per kilowatt hour for the remaining years. So this is a project to do. We want to see at the end if this project is good or not. This is why, on the economical level, of course, this is why we should do a life cycle cost analysis. So the purpose of a life cycle cost analysis is to determine if a project is viable or not. Okay, so if it will give us at the end of lifetime a certain amount of money that is high enough to compensate the investment, to compensate the maintenance, and of course to compensate risks that we can have in any project. So of course a balance of zero is not good, because at the end I want to earn money, and also in this case I cannot just gain a small amount, because I should take into consideration many risks that can happen. So I should make sure to have a high gain. Okay, this is how, and we will assess this, as we will see, by what is called the capital enrichment rate, which will find what is the benefit at the end of lifetime. So it is the NPV, net present value. The net present value will assess the gain relative to this time. Now, what do we mean by this? Because you know that now if you have $100, you can buy something that has much more value than after 10 years, because in general with time the value of money will decrease, and what you can buy now, it's not what you will buy after. This is why we say that always when we do the economical assessment, we do relative to one time, which is the current time. So when we say net present value, this means that we will assess the value of the incomes relative to time zero. Okay, this is why we will see in the formula here. These are the formulas we introduced last time, and you can see them again in the videos. Okay, when you want to study the life cycle cost, LCC is life cycle cost, NPV is net present value. Okay, as its name indicates, life cycle cost is the total costs you will have to pay during the lifetime of your project. So in order to assess the life cycle cost, first you should take into consideration what is the initial investment, I. You should take into consideration also the operational costs, and so this is the operational cost, and this is the maintenance cost. Okay. Now, why we divide here by 1 plus 8 to the power up? Because as I told you, you have always risks with time. And what you can buy now with a certain amount of money, you should have more money to buy it after. This is why we say we will define, to take these risks into consideration, we should define a certain discount rate A. This discount rate represents what is called the confidence in the future. So if I am really very confident in future, this means that I think that everything is stable, the value of the money will remain the same, then I will take A0. And if A is 0, this means that the value of the money now will be the same after. But in general, it's not the case. A, which is a discount rate, in general, it is in the range from 1 to 10%. Okay, because if my confidence in future is not high, I will not invest. Okay, because you know that to do an investment, you should be confident about the state and about the country, about the state of the money, etc. Because if you have high fluctuations in currency and in financial um, factors, then you will not do a project and put money because you might not be able to gain this money again. Okay, so this is very important. This is the time factor is very important, and it is affected by the the currency you are using. And of course, if you are investing, um, let's say in a country as United States, it's not like if you are investing in Lebanon. If you are investing with dollars and you can gain dollars, it's not like you are gaining Lebanese lira, of course. So all of these factors will be taken into account when you are putting your project, when you are deciding if you will go for the project or not. Okay, so then here, once we decide about here it's a subjective estimation sometimes, because you know that you have a lot of factors sometimes you cannot predict. It's true, for example, if we take the case of Lebanon, it's true that Lebanon was always risky, and always we had a lot of factors that we cannot consider. But for example, what happened these 2 years is not predictable. Sometimes you have very high you have certain accidents that are not, you cannot never predict them. So in this case, of course, this is why sometimes we should take a risk. Even with all analysis we do, we might have risks that are not predictable. This is why we advise that when we want to do a project, we should try to say that we know that we have risks. So it is good to take a high value of A. Even if you have good factors, try to be on the safe side and select a high A, because when you select a high A, this means that you are not very confident in the future. And then you should take into account that I might have a lot of risks. This is why I should gain more in order to set my project to be profitable. So this is why once you decide on the value of A, you can estimate what is the net present value of your cost. So let's say if you say I have a maintenance cost of $100 per year, for example, okay, you will say that for the first year, the cost I consider will be, let's say, 100 over 1 plus A, because with time the value of this $100 will decrease. So for year 2, this cost will be 100, because each time you will multiply your operational or maintenance cost by 1 over 1 plus A, because the value of your money will be يعني, with time you can buy the same thing with a lower amount of money. Okay, so since each year you are multiplying by 1 over 1 plus A, then at the end for a year I, you will divide your cost by 1 plus A to the power I. Now this is good for the cost, because with time, if you want, the cost value is decreasing for you. But on the other hand also, the income is decreasing, the value of income is decreasing for you. This is why we should take, and this factor will not be of benefit, because at the end the balance between what is important for me is the balance between income and cost. So of course for the cost, the value of the cost will be reduced because I'm dividing by 1 plus A to the power I, but also the income is reduced. And what I care for is the balance. So with time, what I am gaining is losing its value. This is why if I am setting A equal to 10 and still I have a benefit, then I can say that it's good to go for this project. In case it's not, so for example, if you set A close to 0, then you are very confident, and maybe you will have other factors that will affect your project, and it's not good if you want. So the higher is A. If your project is profitable for high A, then of course it will be profitable for small A. Okay, because more you decrease your confidence in future, more you will have a if you want your gains will be reduced. So if you do your analysis on 10%, you can be sure that if A is smaller than 10%, it's very good. Okay. So, and finally, in the life cycle cost, in addition to the operational and maintenance cost, we add the investment, which correspond to year 0. So investment will take place at year 0. Okay, and for all other years, we should include operational and maintenance costs. Now, at the end, the salvage value you should subtract. Why we subtract it? Because we will gain money by selling the equipment at the end of its lifetime. So this is why when we want to assess the life cycle cost, we should subtract the salvage value, because this will give us money, since we can sell the equipment. So this is the whole costs we will have during the lifetime of the system. Now, if we want to assess the benefits, the incomes, we will calculate the net present value. The net present value represents the gains at any year. And you can assess the net present value at the end of lifetime. So if you put net present value at n, this means I will consider the whole lifetime. If I don't want to consider the whole lifetime, if, for example, let's say here your turbine has a lifetime of 20 years, okay? In case you want to assess what will be my gains after 10 years, you can calculate NPV at 10 years, but please pay attention. I should not include what? When I want to calculate NPV at 10 years, should I include the salvage value in the life cycle cost? What do you think?
No, because it's at the end of the 20
Exactly,
years.
exactly. So if I want to assess the net present value at 10 years, when I calculate the LCC, I should not include the salvage value, because the salvage value I can get it only after 20 years. So what I should do then to calculate the life cycle, and it will not be also if you want the life cycle cost, it's until 10 years. Yani I will just calculate the investment plus summation from 1 to 10. Okay. So I can calculate the cost at any year I want. Just I should not include the salvage value, and I calculate the summation from year 1 to, let's say, year 10. Okay. Then to calculate the NPV at year 10, I just should subtract the cost from the income. Okay. So if you want here, the NPV for year n, or for year 10, for example, will be minus I plus summation from 1 to 10 of the balance between incomes and costs over 1 plus a to the power I, and I don't include the salvage value. Okay. While if I want to calculate the net present value at the end of lifetime, then I should assess the life cycle cost from the first year to the final year, and I should then add at the end the salvage value. Okay. Is anything not clear here about the formulas? Okay. So now let us see what do we want to find in this problem. The first question is to determine the rate of return on investment. So first, by definition, what is the rate of return of investment? If you remember, the rate of return of investment is the discount rate A, okay, for which the net present value at year n, which is the end of life of the equipment, is 0. So this means that I didn't gain anything, I didn't lose anything. Just the balance will just be 0 at the end of lifetime, which is not good, of course. If you tell anyone that you will go through a project and at the end you will just earn what you put as the cost and investment, no one will go through the project. But this ROI is important to assess. I will tell you why. Because from your ROI, you can know if the project can be, I can go through the project or not. How? For example, if you perform your calculation and you obtain that the ROI is equal to 20%. What can you conclude from this? If I have a discount rate, if ROI equal to 20%, what will happen if A will be smaller than 20% for the NPV, for the net present value? Sorry, I had an electricity cut. Do you hear me now?
Yes, we all did, doctor.
Okay. Yeah. Do you see the screen again?
Yes.
Okay. So we were saying, we were talking about the importance of the rate of return on investment. So why we assess it? Because once you determine the ROI, you can say that if your confidence in future is smaller than the ROI, then your net present value will be what? What do you think? It will be positive or negative? The net present value represents at year end, represents the gain at the end of lifetime of your project. ROI is just the discount rate required to get NPVN equals to 0. If A is smaller than ROI, what do we mean by this? Yani we are more confident or not in future? Look, when you divide the value of your money, okay, it at each year is divided by 1 plus A. This means what? This means that higher is A, lower is will the value of your money, lower the value of your money will be after. This means that once A is higher, then you are not very confident in future. Okay, so now for A smaller than ROI, then you are more confident in future. If you are more confident in future, if ROI will give you a net present value at year end equals to 0, then for a discount rate smaller than ROI, you will have NPV at year end larger than 0. Okay? So the ROI is very important to know what is the interval of confidence in future we can have. So higher the ROI, the better is. Why? Because you will have a larger interval of A. And for example, here, if ROI is 20%, this means that for any discount rate smaller than 20, so between 0 and 20% confidence rate, this will give me this will give me net present value higher than 0. Okay? And if the net present value at year end, I should have it larger than 0. So of course, here, since I have a large interval, this means that when I have relatively small A, of course, I will get a good net present value. So if I take a discount rate of 5%, for example, then of course I will obtain a good net present value. On the other hand, a small ROI is not a good indication. So if you performed your calculation, for example, and you obtained that ROI should be, let's say, if the ROI is 2%, for example. This is very bad. Why? Because this means that even if I am very confident in future, my net present value will not be as high because 2% is a good confidence in future. Then in this case, even if I have a good confidence in future, my net present value will just be 0. So I should have 1 and 0, yani I should have a smaller than 2, which is very high confidence in future, to get a net present value positive, which is not, if you want, very good, because if any risks will come, I will lose money. Okay, so
Doctor,
yes.
is this related to, for example, investing versus depositing in a bank account? Like we are comparing the interest we get with
Yes, exactly. Look,
return on investment?
yes, I understood. Exactly. So if you will consider also, in general, in countries where we where projects, where we do a lot of projects, the what we get in the bank, the interest in the bank is low. Okay. Of course, if you want to, for example, here in Lebanon, we had previously very high uh, interest rates in banks. This is why no, and the number of projects was reduced a lot, because people prefer to put their money in banks and they will get an interest. Why they want to investigate in projects? So of course, if you have high interest in banks, this will lower also your if you want, then you should assess also what you are losing from the bank, because let's say if you have a certain amount of money, if you put let's say $10,000 in a bank, and you have a high percentage of interest, then if you use them for a project, you should take into account also what you lost from the bank, of course. But here we are just considering in cases of countries where we don't have these high interest rates, and in general, in developed countries, the interest is less than 1%, and in banks. This is why you have more interest in projects, because in projects then you can gain more money. While if you have high rate of high interest and high rates in banks, in this case, you should consider what you are losing, of course. Okay. Here in this analysis, they didn't account for this, because if you want, here we just considering that the interest we can get, it's not as large, and we can neglect it compared to the gains that we will have from the project. But it's true what you are saying. It's true completely. So if I have the option to have a high interest rate in the bank, of course I should consider what I am losing, and I should compare. Then in this case, as you are comparing two scenarios, in this case I should subtract from my gain what I could have gained in the bank, of course.
Which is the opportunity cost, in fact.
Yeah,
Opportunity.
exactly. Here they didn't take it into consideration, because here, if you want, and this method of calculation is not considering that you have the possibility of having very high interest rates in banks. Okay. Okay. So now, and of course, even if you want, the calculation here have several limitations. First, as you said, we are not considering the possibility of interest rates in banks. Plus, also we are setting A as constant through the lifetime of the project, which is also not a very this assumption should be carefully taken, because with time, you can have more risk, especially if you have a high lifetime for your project. But this is why we can just set a certain average confidence value depending on the state that we are in. Okay, so um, so taking into consideration all these limits, this is why at the end you will see that after we do the analysis, we will say that because this method has a lot of assumptions, we are not considering interest rates of banks, we are not considering that the confidence future might be variable with time. This is why at the end, to assess the profitability, we do not state that just NPV should be positive. Okay, because it's not enough to have NPV positive, since we should account for many risks and many limiting assumptions that we have taken in the analysis. This is why, to take all of these risks into account, we say that to consider my project profitable, I should calculate the CER. which is the capital enrichment rate. And the CAR represents the ratio of the net present value at year end, okay, over the number of over the investment. The investment I have done at the initial stage, okay? And we say that it should be larger than 0.3 in order to say that my project is profitable. So at least I should gain 30%